Hi, Jonathan Schwartz here with Integrated 3 CPM. Just want to go over a little bit on stats and statistics and how to do mean and standard deviation of the sample and standard deviation of the whole population with the TI-34 Texas Instrument Calculator. It'll be the same for all the TIs. So let's say I have 5 grades on a quiz. Let's say the quiz is out of 20 points and these are my 5 grades. I could create a frequency distribution, which is really X, the value, and then frequency, how often they occur. So I could do it like that. I have one of these value, 18. I have one of these, 19. I have 2. 20. I have 1. So you can tell in this case it doesn't make too much difference for saving times, but if I had 100 test scores, it would make a big difference. So here are my 5 data points. These are really one variable statistics. I'll go over how to do it with paper and pencil when I'm done with the calculator. So these calculators are really designed for stats. So I don't know if you can see this too well, but here's the stat key right there. So the first thing I have to do is put in a stat mode. It is a secondary function, so I have to use the second button. So second stat, I'm going to run one variable statistics. So I hit enter. And now in the lower right hand corner it says stat right there. So now I'm ready to do statistics. So first thing I do is I enter my data. So I hit data. X1 was 17, and I could arrow down frequency 1, and X2, my second data point, is 18. Arrow down, I have one of those values. My third value is 19. Arrow down, I have 2 of those values. And now my fourth value, since I'm doing it as a frequency distribution, is 20. And then arrow down, and enter. Okay, so I'm done entering my 5 values in a frequency distribution, total of 5 values. So now I want to run analysis on it. So I hit this button right here. I know it's hard to see. So I hit this, and then I have a menu here. So n is a number of values. I have 5 values. Use a Sharpie. So n equals 5. I arrow over, x bar is 18.6. And I'll arrow over, lowercase s with an x. That's standard deviation of the sample. So s, standard deviation of the sample, is 1.14. The other notation that's common is a standard deviation sub s. Standard deviation of the sample could be represented with a lowercase sigma sub s. And I'll scroll over, and then a lowercase sigma is just standard deviation. 1.02. Okay, so those are my stats. I'm all done entering my stats here. I could hit clear. I'm still in the stat mode right there, so I'm going to hit second, exit stats. Do you want to exit? Yes, I do. And now I'm out of stats. Just while I have you here, I'll just point out this other notation here is RAD. That's for radians versus degrees. So if you're doing trig, you want to make sure you're in the right mode. You change that right here with the DR button. So now, let me clear out of here. It's a second function, so second. Do you want to be in radians or degrees, whichever one's underlined? And now I'm in degree mode. Okay, so let me show you how I do this with paper and pencil. I still need a calculator. I add up these 5 values. So I'm going to add up 17 plus 18 plus 19 plus 19 plus 20. They all add up to 93. 93 divided by 5 is equal to 18.6. So that's how I get the average. Okay, the standard deviation of the sample. So let's say I had a class of 30 and I only sampled these 5 right here. So this is sample statistics, and I'm trying to figure out how well this represents the whole. The way I calculate standard deviation of the sample, it's equal to the square root of 1 n minus 1, the sum of deviations squared. And it's kind of intimidating notation, but it's actually not that hard if you break it down. So n is a number of values in the sample. Capital sigma is the sum of a column. It's a value, average value. So I'll create a column here, x minus x bar squared. So what I'm going to do there is my average is 18.6. I'm going to go 17 minus 18.6 equals, and then I'm going to square that and get 2.56. So this is 2.56. 18 minus 18.6, 0.6 squared, 0.36. 19 minus 18.6, my average, 0.4 squared, 0.4 squared. 20 minus 18.6, my average, 1.4 squared is 1.96. So this is a deviation squared. This is a deviation squared. Looking down at my, it's kind of like a road map. The sum of deviation squared means I take all my deviation squared and I add them up. 1.96 plus 0.16 plus 0.16 plus 0.36 plus 2.56. So the sum of deviation squared is 5.2. So this whole thing right here, the sum of deviation squared is 5.2. So 1 over n, the size of my sample, 5. So 1 over 4 times the sum of my deviation squared, and then the square root of that. So I take 5.2 on my calculator, divided by 4 equals, and then I'm going to take the square root of that value. The square root of my answer, and I get 1.14. So I don't know if you see that there. So the standard deviation of a sample is 1.14. I could do it with paper and pencil, or I could just use a calculator. Okay. Last thing I just wanted to mention, let's say I only have 5 people in class, and these are all of my scores. So I'm doing whole population stats now instead of sample stats. So whole population, so this is standard deviation of the sample. If I were in fact doing standard deviation of the whole population, everything's the same, except I do not divide by n minus 1. I divide by 1 over n. So this is 1/5. Deviation squared will be the same. The sum of deviation squared will be the same. So I take that 5.2 divided by 5 equals, and then the square root of that answer equals 1.02. So this is equal to 1.02. So just to summarize, easy to do with the calculator. That's what these calculators are designed for, is stats. Paper and pencil, x is your values. X bar is your average. You find that by adding all your values up, dividing by the number of values. S, or sigma sub s, is standard deviation of the sample. And this lowercase sigma is standard deviation. The difference between these two, one is sample statistics, meaning I draw a portion of the test out to see how well they represent the whole, versus whole population where I have every test. So an example of that would be, let's say I have 5 people in class, I have all 5 of their tests, I add those 5 people's tests up, divide by the 5 people, and I get an average and a standard deviation. So that's whole population. Another example is I have 30 students in class. I pull out 5 randomly. I add those 5 up. I get the same average. But to find the standard deviation of the sample, I divide by n minus 1 instead of by n. Okay? So that's the big difference between sample stats and whole population stats. The ideas are big, the difference between the two. So hopefully that'll give you a better overview of it all. Thank you.